Good morning all. Myself Helen George, register number NSS 17CS029. We are group 3 and our group members are
Myself, Anisha Menon, register number NSS17CS017.
Myself, Anto, register number NSS17CS019.
Myself, Kadeeja BH, NSS 17CS032.
Our project is real-time traffic detection from tweets. We are guided by Assistant Professor Chitra as ma'am. In this grateful occasion, I would like to thank her. Thank you so much, ma'am. So let's move on to our project. Today we are going to discuss in three parts: code, result, and output demo. So what we have done on our project is a system which collects tweets from users, apply various pre-processing steps, feed it into our pre-trained CNN model and predict whether the tweet is traffic related or not with location, time and date. Since our project is a traffic based, location is one of the important parameter. It is fetched with the help of some geocoding techniques or Twitter APIs. The existing models are basically hardware based or machine learning based models. Our system outperforms those with an overall accuracy and F1 score of 98%. That's all about introduction. Next, I'm going to take you through our code. First part is pre-processing. We import all the libraries required. Next, we define four functions to remove emojis, punctuations, URLs, and to lowercase the tokens, and also to remove the stop words. Then we read the dataset using a read CSV function from pandas, and a data frame is created. Then we remove all the emojis, URLs, and punctuation using the function defined above. And here we used a tokenize function to convert the tweets into tokens. Then we lowercase and also remove the stop words using the function defined above. Next we create an internal vocabulary. Next we split our dataset, training dataset into training and validation dataset with a split ratio of 0.2. Next, we find the maximum training sentence length and total number of words for training data. In the next cell, we find the maximum sentence length and total number of words for validation data. Next is padding. Here we used post padding technique. Next, we load the word2vec from word2vec Google News 300. Next, we create an embedding vector and an embedding matrix with an embedding dimension of 300. Next, an embedding layer is created with an input length as a maximum sentence length. Next, I'm handing over to Kadeeja to take the remaining sections. Thank you.
Thank you, Helen. Now to construct the model, we add on layers. There are 5 layers for the CNN model. Let's talk about the very first layer, that is the embedding layer. It takes input length equal to sequence length, and the input sequence length is 24. Then next we have convolution layer. Here we have one-dimensional convolution layer, and which consists of 128 different filters. Here our kernel size is 2, and the activation function used is relu. As kernel size is 2, the sequence length 24, it would look at 2 words at a time, and the next 2 words, and so on. Then we have a global max pool layer to get the most important features. Then we have used dropout layer to reduce overfitting. And finally, we have a dense fully connected layer for the final classification. And then we print out our model summary. Here we have the model summary. First of all, the embedding layer of sequence 24 and which has 300 bits as output. And in the convolution layer, there are 128 filters. And for the max value of 128 dimensions as an output of the array, we have taken all the max values. And then we have the dropout layer of the same size. Next, we perform training. Next cell. Yeah. So then in the first of all itself, we perform fitting, running, epochs, and also finding accuracy. For that, we have xtrain, which performs data training, xvalid for which performs data validation, labels for label training, and validation for label validation. All along, we have batch size of 64 and runs to 20 epochs, and which finds accuracy and loss of the validation set. In the next cell, we have saved our model to model.h file. Yeah, that's it. Handing over to Anisha. Thank you.
Myself, Anisha Menon. So the next part is framework. So the framework that we will use on here is Django, since our project is highly expandable. So as like Kadeeja already said, the model is got saved into model.h5 and we loaded or reloaded that model into a reconstructed model. So the next part is to create the index page. So our index page is home.html and this is our home.html. So there is so on here we created a button. So by clicking on that button, the request will get loaded into our output function. So what we done on this output function is basically fetching the tweet for our real-time prediction. So after creating the business account in a TweetPy, we will get some Twitter, we will get some private keys. So with the help of that private keys, we authenticate the user. So after authenticating the user, the next step is to create a query list. Query list basically contains a list of keywords that is directly related to road traffic. So as I already said, our project is dealing with the road traffic. So location is one of the important parameters. So to obtain those location related information, we use the GeoSearch API for here. So the next part is to finding the time zone detection. So the time zone detection is done since the time zone which was used by Twitter is directly on a Greenwich Meridian time, and we trying to collect the data on New York. So that's why we need to convert the time zone. That's why we use some time zone functions. It's also a Python library. So the next part is important part. That means the tweet fetching. So the fetching of a tweet is done with the help of a tweetpy.cursor. So with the help of this tweetpy.cursor, we will collect the tweet that is related to these keywords in New York City. And in that manner, we collected 10 tweets from each of these keywords. So after collecting it into the JSON format, the next step is to save that into a CSV file. So for that, we created a CSV file called as the tweetcollector.csv. So after creating a CSV file, we need to filter the tweet. So the filtering was mainly done based on the time at which it is created and the date at which it is created. So according to the researchers, it is found that the average time of traffic in New York City is 55 minutes. So that's why we apply some time constraint on over here. So after applying on here, the next process is to store the data like created at a time of a creation, as well as the tweet location and the text into that CSV file. So as I already said, the time zone in New York is different. So that's why we apply a time zone conversion over here. Since the time zone conversion, since the time zone on New York is a -4 from Greenwich Meridian, we apply that function on over here. So after writing it into the CSV file, the next step is pre-processing. Pre-processing is already taken by Helan. It basically includes the removal of emojis, URLs, punctuations, tokenization, lowercasing of a tokenization, removal of a stock. So after padding, the next step is to feed this data into our model for prediction. So the prediction is done with the help of a predictive program. So with the over our model. So after receiving the predicted result, we feed it into our CSV file. We created another CSV file called as a tweet final. On that, we fed these data like time at which it's created, then the time at which time now on New York City, the date of creation of a tweet, tweet ID, the location, tweeted result, as well as the tweet. Our CSV. So after that, we render it into our table.html. So what we done on this table.html is that it basically contains these columns. The first column is the serial number. The second column is date. Date means the date at which the tweet is created. Then the next column is the time New York now. That means the time of New York now. Current time of New York. Then the next is a tweet created at time based on the New York time zone. And the next is a tweet created time based on our Indian standard time. Then the next column is a tweet. Tweet means the collected tweet details. And the next is the location. Location is the location of which the tweet is get posted. Then the next cell is a prediction. Prediction indicates the column with the predicted value. So that's all about our code. Thank you. Handing the session to Anu for discussing about the results. Thank you.
Thank you, Anisha. Myself, Anu Anto. After training our model, we have to know how good is our model. For that, we have plotted the loss and accuracy graph. First, we have plotted the loss graph for the training data as well as for the validation data. If you look at the graph, we can see that the loss curve is decreasing. Loss is decreasing when the epoch is increasing. Next graph is the accuracy graph. If we look at the graph over here, the accuracy is increasing from 0.972 to 0.980. Then next is ROC curve. It is a plot that evaluates a set of probability predictions made by a model on validation dataset. The false positive rate is plotted on the x-axis and the true positive rate is plotted on the y-axis. A diagonal line on the plot from the bottom left to top right indicates the curve for no skill classifier, where the predictions will be, in almost all cases, will be negative class. And a point in the top left of the plot indicates a model with a perfect skill. The curve is useful to understand the trade-off in the true positive rate and false positive rate for different thresholds. The area under the ROC curve, also called AUC, provides a single number to summarize the performance of a model in terms of its ROC curve with a value between 0.5 indicating no skill and 1 indicating perfect skill. Here we have used geometric mean as a metric to locate the threshold with the optimal balance between false positive and true positive rate. The next, the best threshold value and the G-mean value obtained is shown over here. Next is confusion matrix. For plotting the confusion matrix, we have used plot confusion matrix function. The output is shown as a figure here. We have got a true positive value of 5012. Similarly, false positive, false negative, and false true positive is shown over here. Next, we have printed a table of precision recall and F1 score values for the positive and negative labels. Next is our output, which will be taken by Anisha. Thank you.
So thank you so much, Anu. Myself, Anisha Menon. So coming to the output session, what we've done on here is first, as I already said, we created a developer account. So after creating the developer account, we will get some private keys. So with the help of that private keys, we authenticate the user. After authenticating, the next process is a tweet fetching. So the tweet fetching, after the fetching of a tweet, some filtering is we applied based on the geolocation, the date and time. So after applying this filtration, we will get some output, and that output, that means that tweets, after applying these filters, is get stored into tweet collected.csv file. Then the next process is a pre-processing of this data. So after pre-processing of this data, the next process is a prediction. Prediction is done with our model that is already trained, pre-trained model. So after the prediction, with including the predicted result, we saved all the results into our tweet final.csv. It basically contains the serial number, time in New York now, and the time at which the tweet is created based on the New York Standard Time as well as based on the Indian Standard Time. Then that our tweets, then along with the location at which that tweet is get posted. And finally, the prediction. Those are all get saved into our tweet final.csv. Then we printed our tweet final.csv into the web page. So that is what we done flow of our output demo. So this is the basic UI that is created. So there is a button over here called as a detect traffic. So it is the button that we use. So by clicking on that button, the output will be like this. So this is our output. Will be like. So coming to the demo session. So as I already said, this is our home page. So there is a button called as detect traffic. So by clicking on that button, it will take some time. As I already said, we collected at 50 tweet, and after collecting those 50 tweet, we want to apply some filtration and then prediction. So it will take around 23 seconds for loading. So this is our final output. So the final output basically contains the serial number as well as the date at which the tweet is get created, then the time of New York now. So that means the time, current time in New York. Then the tweet created a time based on New York time zone as well as based on our Indian time zone. Then the tweet, and the next one is a location. Location is basically the location at which the tweet is get posted, and finally the prediction. So since our project is mainly said that real-time traffic detection, we fetch the data in real time by using the TweetPy library, and so the time is also time at which creation is also given. So yeah, this is our final output. So thank you so much. So handing the session back to Anu for conclusion. Thank you.
Next is our conclusion. Based on the results of design, analysis, and evaluation of the experiment, it can be concluded that the model was successfully tested with an F1 score value of 0.98. Using the word embedding in the proposed model as an effect on the F1 score value, it has increased from 0.95 to 0.98. As a future work, we can collect more data for classifying traffic-related tweets into detailed categories like traffic accidents, or if the traffic is due to some external factors like soccer game or procession or manifestation, etc., or not. And we can also use a deep convolutional network for short message classification. Next is our timeline. We have completed our project in the timeline shown over here. Rest are the references which we have used. These are our references. Next slide. Thank you. Thank you all.